right, hello and welcome. It's been a while since I've seen a lot of people, and it's always great to be back. I thought I'd do another live stream. Actually, you'll probably see a few live streams this week just because I feel like getting out, answering questions, and doing a lot of fun math. So I'll probably put another one on the schedule. If you're interested in these, you'll probably see a few more show up this week. As always, if you have questions or things that you want to know, feel free to drop questions in the chat box. Feel free to send them to my email. Either way, I'll get to them, and we'll go ahead and just answer some fun questions. These could pertain to math or anything in general. I'm open to anything. Though I guess I gotta get my pen if I'm going to draw anything. Yeah, let's just see what we want to know today. All right, let's see what we got. There, I think that'll work. If you don't have any questions, of course, I always find a few just roaming around the internet that I pick up and like to do along the way. I think I found one. It's just a matter of making sure that it actually shows up on the screen here. There we are. Cool. All right, so let's see what this first one says. This first one says we have a diagram, and we want to use the diagram below to answer the question. So it looks like we have a couple of squares. One is 1,600 meters squared. The other one is 900 meters squared. And our goal is to find the area of each square. Given the area of each square, we're supposed to find the value of x plus y. Sounds good to me. So when it comes to finding the area of a squared, we're really just looking at the area of a side squared, and that should give us the total area. So if I'm trying to figure out information about x here, then what I can do is I can set x squared equal to the 1,600. Now, in a similar way, we can do the same thing for y. So y squared would equal this 900. Okay, now that we have each of these individually, we can go ahead and solve for x. So taking the square root of both sides, looks like this will give me a nice, what is that, 400. Well, that might be a little large, huh? 40 times 40, that will give me 1,600. Let's take off one of those zeros. For the other one, let's see, if I take the square root of both sides of this one, I'll get 30. Okay, so now that I have the value of x, I have the value of y. Now we can really just add those together. So x plus y, this would give us the 40 plus the 30 for a grand total of 70. And that would be the value of x plus y. Let's see, there are units for this one, so we would also want to include the units, and these are in meters. All right, let's continue on. Okay, it looks like the next one says, what is the value of the expression? We got a lot of different terms in there. Let's go ahead and clear our whiteboard a little bit. So this is dealing with a -4, the square root of 25 plus 4 cubed. So I first need to really take care of that square root of 25. Well, the square root of 25, if I'm thinking of two numbers that multiply to give me 25, that would have to be the 5 and the 5. So negative 4, this will be multiplied by 5, and now we need to take care of the 4 cubed. 4 cubed is really just 4 times 4 times 4, so I'd really think of multiplying all of those together. 4 times 4 is 16, times another 4, that would give us a 64. Excellent. So now we just have the negative 4 times 5, that is a negative 20. So in the end, we're taking a negative 20, adding a 64 to it. That'll give us a grand total of 44. Let's go ahead and put a nice little red box around that so we know which one we're looking at. Very nice. All right, let's see what else we got. All right, this one involves simplifying an expression. Well, it looks like I've ran out of space. I have to clear this one out and make some space of our own. So what is the simplified form of the expression? Okay, looks like we're combining like terms for this one. So I'm going to start it with a 6. Let's move that down just a little bit. I'm going to start off with a 6x to the 4th plus a 4x cubed minus a 2x squared plus 5. So that's really just everything from our first expression. And then I'm going to distribute that negative sign into the second expression. That way all of the terms will have the proper sign on those ones. So let's see what we got. We got a negative 3x to the 4th, a positive 2x to the 3rd power, and then a minus 4. So really when you write it out like that, you really want to start identifying what are the like terms so that you can really start putting those together. I'm going to underline them just so I have a really good, clear visual of which are the like terms. For example, I can underline in red all of the ones that are x to the 4th. Then maybe I'll grab the green marker here. Everything that is an x cubed, I can underline that one. I only have like one term that's an x squared, so I'm not going to worry about underlining that one, but I will underline all of our constant terms. Those are the ones that do not have an x whatsoever. So, I can go ahead and just underline those. All right, now we can go ahead and combine our like terms. Let's see what we got here. So combining the red terms, this would be the x to the 4th terms. 6 minus 3, this would give me a 3x to the 4th. Then combining the 4x cubed terms, so 4x cubed plus a 2x cubed, grand total of 6x cubed. Then I only have a single squared term, so I guess I'll just write that out. No need to combine that with anything. 5 minus 4, that'd give me a total of 1. And now I have my simplified expression. There's no other terms I could really combine with this, so this is as simple as it gets. Excellent. Well, it looks like the next one involves trying to identify which of these is a negative slope. Let's go ahead and clear our whiteboard and make sure we got some space to answer this. There we are. So in this one, we're really just supposed to identify which graphs have a negative slope. And if I'm trying to figure out the negative slope, what I'm doing is I'm reading it from left to right. So really look at these graphs from left to right. And I'm trying to figure out which ones actually go down. Oh, welcome. Looks like you just dropped into the stream. Sure, I can definitely help you with an equation. Let me do it after I finish this problem, though. Looks like you're doing a 3x plus 1. Sounds fun to me. So yeah, with this one, we're looking for the negative slope, and of course, we're going to read this from left to right. The reason I'm reading it from left to right is, in my mind, I like to think of these like a roller coaster. And if I think of them like that, then anywhere my little roller coaster would be going up, the function has a positive slope, or we're increasing. Anywhere we're going down, it has a negative slope, or we can say we are decreasing. So of the two graphs that I'm looking at right now, the second one right here has a negative slope. You can see that it is going down as we read it from left to right. Now there are a couple of options also in this one that are off the screen, so let's go ahead and scroll and see what those look like. This first one has a positive slope because it is going up, and the very last option has a slope of 0 because it's not really going up or down, it's really just staying constant. Sure, okay, so it looks like you need help with an equation. Sounds like a great idea. And the equation that you're looking at is a 3x plus 1. Sounds perfect to me. What do you want to know about that equation? I'm going to write it down just so we have it really, down on the page. We can look at it. So y equals, this is a 3x plus 1. Awesome. So when I look at an equation like this, I can see that immediately it's in what is called a slope-intercept form. And it's good to recognize that it is in that form because it tells me that from the equation itself, I can read off those bits of information. So this 3 actually is what we call the slope. And this 1 is the y-intercept. All right, so if I had those two bits of information, we could actually graph this fairly easily by using the y-intercept as like a starting point, and then using the slope as a way of figuring out how to get to other points on that graph. Let's give it a try. It's on the board anyway. Why not? I'm going to grab my ruler here, see if I can draw some nice straight lines. There's one. Excellent. All right, so I need some little tick marks in here. Let's just put a few along the y-axis here. We'll put a few along the x-axis. Should probably label our x and y-axis just so we know which is which. Now let's start putting down some points. So in terms of the y-intercept, we know for sure it goes through this place on the y-axis. It goes through right at 1. If you want to label that, that also works. So this is when x equals 0, then y is equal to 1. And to build further points from that one, then you really start at that anchor point, and I could go up 3 and to the right 1. What I'm doing there is I'm interpreting the slope as a fraction. So our current slope is 3, but I'm really looking at that as 3 over 1. And that tells me how I'm going to get to a new point. So this 3 is telling me I would go up 3 units. And then the 1 is, that's what's really telling me to go to the right 1 unit. All right, so starting at 0, 1, I'm going up 1, 2, 3 to the right 1. And that would give me a second point. Cool. Once I got 2 points, I can go ahead and connect these, and we will have our entire line. Let's go ahead and do this in green. And just so we're super clear where that second point is, this other one is located at 1. So it's gone to the right 1, and it's gone up 3, so this should be at 4. So that'd be the equation of our line. Does that help out a little bit? Good to know. Excellent. What other thoughts or questions do you have on your mind? Well, hello, why not? How's it going? I really help with any type of math. I've been doing math tutoring for many years, so if you got a question, feel free to ask it in the chat box. Of course, there's no guarantee I'll know how to help it, but chances are I've seen a lot of different questions. Chances are we'll be just fine. Yeah, trigonometry can be confusing, so if you have any trigonometry questions, I've switched it over to the purple background. We can definitely do some trigonometry. I think I might have a trigonometry question. Well, that's okay. If you're doing algebra 2, I like that topic as well. Let me switch to my algebra background. So, if you do have a question on algebra, I could probably write it on that one. I like to color code my different backgrounds so that when I'm looking at them later, at a glance, I know what subject they came from. So if you happen to be wandering around my channel and you realize that some of the backgrounds are different, that's just because they come from different subjects. So any background that's red, that one's probably from algebra. Any one that's purple, that one comes from trigonometry. Let's see, what is it? Orange is calculus, and I think the yellow, that'd be statistics. What is that? CXC past papers? I don't even know what those are. Let me go look them up. Caribbean Examination Council. Oh, those sound like fun. Do they have any practice tests for, what was it? Practice papers for math? Here's one. Looks like different companies do them. I might have to do some searching for various different past exams. Or you can send them to my email. That's another good way I can get a hold of them. Will do. Okay, so let's do past CXC exam PDF. Let's see. What do they got? What do they got? Art, chemistry, communications, mathematics. That's what we want. Moderator form, syllabus, subject reports. So where's the actual papers? Ah, here we are. Perfect. Let me see if I can bring it up on my little screen as well. Cool. I'm going to switch over to a different background for some of these. And we'll go from there. Let's see if I can get at least one of them on the screen. So it looks like this one has 50 questions. Wow, 50 questions. You get 1 hour and 15 minutes to do them. Most of them are multiple choice, so it's really a matter of just kind of looking at them and yeah, figuring out which is which. Let's see if I can put a few of these on the screen here. Alright, I need to scale that down just a little bit. Perfect. All right. Here's the first one that I got from a practice exam for the CXC. This first one simply wants to know what is the value of 6 in the number 7,685. So when you have a number like this, every single location or place value of the number has a different value. Now, of course, we use a base 10 system, so that 6 is one of those powers of 10. Since it's in the third spot, we would consider this to be 600. The other numbers in there also have value in case you're curious about those ones. For example, the 8 would represent 80. The 7 would actually represent 7,000. Is there one more? Yeah, there's one more number. That'd be the 5. So this problem is only asking about the 6, but you can see what the other numbers also represent. Moving on, let's see what else we got here. Boy, sometimes my scroll is really sensitive. Let's see, does that work? Oh, kind of cut it off just a little bit. All right, that'll work. So this one says, which of the following is a composite number? So a composite number, that's some special vocabulary. It means that we can break it up into factors that are not equal to 1 or equal to the number itself. And it's a way of really indicating that it is not a prime number. So we have prime numbers and composite numbers. Prime numbers, when we go to break those ones down, can only be broken down into 1 and themselves. So as we're looking at this list, we're looking for the one number that is not a prime number. Let's see what our options are. So we have 19, we have 30, and we have 47. So 19, if I try and break that down, nothing goes in there evenly. The only two that I have would be the 1 and 19. So I'm going to call this a prime number. When it comes to the 30, that actually breaks down quite a bit. So that'd be 2 times 15. And the 15 would be 3 times 5. So that one is definitely a composite number. And then the last one is 49. It's a fairly big number, and because it's fairly big, our gut reaction says, well, maybe it is a prime number, but actually that one is a prime number. The only two things that go in there would be 1 and 47. So the one that we'd select for this one would be option B is the composite number. All right, let's see. This one is also, let's see, there we go. Don't want it to get cut off the screen any. What does this one say? This one says a prime number greater than 21 and less than 28 is blank. So I really want to look at this list and 1, make sure that it is between 21 and 28. And 2, we really have to make sure that it is a prime number. So again, I'm going to look at my options here. So we have a good understanding which are the prime numbers, which are the composite numbers, and really just go from there. So 23, 25, and 27. All right, looks pretty good. Now 23 happens to be a prime number. 25, unfortunately, can be broken down. That is our 5 times 5. So we're going to label that one as a composite number. And then our last number here, that also is another composite number. This one happens to be 3 times 9, and you can break down the 9 even further. So that'd be what, 3 times 3? So also composite. So notice how this one's a very interesting wording. Like they want a prime number that's greater than 21 and less than 28. All of the options are greater than 21 and less than 28, so that's not really giving you anything extra. What they really want to know is, can you identify the prime number in this list? And that comes from the first one, 23. If you have a problem like this one, sometimes you might have to go through a process of elimination. Get rid of the ones that you know for sure are not composite. All right, let's see what else we got. This next one says, or this next one is talking about the highest common factor. Oh, very interesting. So the highest common factor, or HCF, of 8, 16, and 20 is blank. There's actually a method that you can use for getting the highest common factor of all of them, and I'm going to show you how that method works, because it's actually pretty cool. So what you do is you start off by writing the numbers that you're interested in when finding that highest common factor. So we have 8, we have 16, and we have 20. So what I'm going to do is I'm going to find a common factor for all of these numbers, and then I'm going to take it out. As we take out these common factors, these numbers are going to reduce. They're going to get smaller. And I want to continue this process until I can't find any more common factors among the 3. Okay, so let's do this with one of them and see where we go. So looking at all the numbers, I know that 2 goes into all of these. So I'm going to write the 2 off to the left here. And then I'm going to kind of write down this upside down division symbol. Because now I'm going to take every single one of those numbers, I'm going to divide it by 2. So 8 divided by 2 gives me a 4, 16 divided by 2 turns into an 8, and 20 divided by 2 turns into a 10. So I've reduced them a little bit. Now I'm going to continue on. So I'm combing through this thing, I'm looking for any number that goes into 4, 8, and 10. And yeah, it looks like 2 also goes in all of them. So I'm going to write the little 2 off to the left and go through another little division process here. So let me get my ruler here. A little upside down little division bar. And then we'll do some dividing. So 4 divided by 2 gives us a 2, 8 divided by 2 is a 4, and 10 divided by 2, that will give me a 5. So eventually we will reach a point where all of these no longer share any common factors. 5 happens to be a prime number, and I know that 5 doesn't go into 2 or 4. So that's as far as I can go with these. Now with the numbers we've collected there on the left, I can use those to build my highest common factor. So 2 multiplied by 2 gives me a value of 4, and that is what I would call my highest common factor. That's really just the 4. Nice. Excellent. This next problem says, which of the following statements is true? So we're given various different inequalities, and we're really tasked with evaluating those and figuring out which inequality makes sense. So this is really a problem of making sure that we know how to evaluate these. Let's do them one at a time. I'm going to write down A. I'm really just going to write down the results of each side. So 6 times 6, this will give us a 36. Is that really less than? Let's go ahead and put a little question mark over there. 9 times 4, so that is also 36. Well, 36 is equal to 36, and the inequality is a strict one, so I know that this one is not true. All right, on to B. This one starts off with 3 times 8, so that'd be a 24. So is 24 greater than, and then I have 6 times 10, so that'd be a 60. So is 24 greater than 60? Nope, unfortunately it is not. So it's not that one. Let's see what else we got. Option C. 2 times 4 is, or 2 times 7 is 14. Is that greater than 15 minus 3? Is that greater than 12? And yeah, that one actually is true. 14 is bigger than 12. So sure, we'll go ahead and mark that one. That is the correct option for this. Cool. Let's see if I can get this one on the screen. Boy, it's just a little bit off. Maybe I can open it up just a bit. That'll work. Welcome. Looks like we have a few people dropping in on the live stream. If you have questions, feel free to drop them in the chat box. When I see them, we'll take a look at them and see what we can do. Yeah, you know, the SAT is an interesting test. Fun fact, I never took the SAT. When it came time for me to go into university, I had an option of taking the ACT or the SAT. And I think the ACT ended up better for my schedule, and I knew that the schools I was applying to really required either one, so I ended up taking the ACT. Other fun fact, I didn't do very well on the ACT. I didn't take it very seriously. I didn't study very hard for it, so I just kind of like, took it without any prep. But it's okay. I still got into university, and that's when I really had a lot of fun with the classes. In hindsight, I probably should have studied a little bit more just to make sure that I got accepted into university. So if you're saying you're studying, I think that is definitely a good idea. Oh, good question. There's probably a formula out there for that. There is. Looks like there is a conversion chart. Let me take that off real quick. So there is some sort of chart. So if you're looking to get a 580, let's see. That's showing up there? Not quite, not quite. So I just did a quick search. This is for the 2014 percentile, the scaled score and the raw score. Okay, so according to the raw score, it says you need to get 43 questions correct to get a score of 580. And if you were looking at the stats from 2014, that'd put you in the 75th percentile, so that's actually pretty good. Yes, there is always a little bit of a delay when it comes to these live streams. That's okay. Oh, I actually don't know if that's specifically for the math section or not. Let's see what this table actually represents. So it says it's the raw score. Let's back up and adjust our search criteria and see what else we got. Okay, so here's one that involves just the math portion of things. Let's see if I can put this on the screen, on my little mini screen. This one for the math portion says to get a 580, you would need to get 36 raw questions. Yeah, raw score. That would also correspond to a 31 on the reading. But a 36 raw score. Yeah, 580 on the math. Okay. Yeah? All right, I'll give it a shot. The 2020 version of CXC? Sure. If you want to reach my email, really simple to find. It really is just my name, MySecretMathTutor@gmail.com. You can throw questions in there, and eventually, I get to them. And if you say that we need to put up some more questions from the CXC exam of 2020, I think that sounds like an excellent idea. I'll sit down with the exam and we'll blow through as many questions as we can. It sounds like a lot of fun. wonder if I still have that other exam up here. Oh, there it is. All right, there it is. Let's give it a shot. So this one says, question number 7 refers to the following sequence. We got 5, 9, 13, 17, and then it goes blank. So we're supposed to figure out what the next term in the sequence is. Anytime you're given a sequence of numbers like this, you should start testing a few things to try and get the next number. In other words, try adding to get to the next number, try multiplying to get the next number. Try any of those things to see if there's a simple rule that can help you get to the next one. Right, so if we go from 5, or if we go 5 to 9, looks like that's a difference of 4. So 5 plus 4 gives us a 9. 9 to 13 would also have to add 4. And 13 to 17 is also adding 4. So it looks like the pattern so far is just adding 4 every single time. So if we had to take a really good educated guess what the next one has to be, then of course we'd take that guess, we'd say, oh, I think we're adding 4 to this. And our guess would be the next one in the sequence would have to be the 21. Now in the actual problem, it says we could compute the next missing number by doing the following little formula here. So one of these should compute to be a 21. We can also see kind of really what's working into a formula. They're building what is known as kind of a closed formula for this. So with this formula, we should be able to plug in pretty much any number we want and get any number in the sequence. I can tell that because all of them involve this like multiplied by 4 piece. But let's take a look at each of these one at a time. So we have option A. 4 times 5 is 20 plus 1 is 21. So yeah, that sounds good. 4 times 5 is 20 minus 1. That'd be 19. So nope, don't want to use that one. Then option C would be 4 times 6. That's 24 plus 1, 25. So not that one. We would select option A. So that's the only one that evaluates the 21. Oh, good question. Thanks. You like my hair? I've been trying to grow it out recently, so yeah, glad you like it. Let's find out. Let's see what kind of calculators are allowed on the SAT. Because you know, the downside is the TI calculators are very expensive. If you want to use one of those, you can, but yeah, most of the TI versions are you're going to spend well over $100 for those. Oh wow, looks like you have a lot of options when it comes to accepted calculators. So according to the collegeboard.org, so this is where you can find information on the SAT. Actually, maybe I can bring it up on my screen here. I'm going to try and open up my little web page a little bit bigger. That way you can see more of what I'm seeing. So if you have a calculator with characters that are 1 inch or higher, or if your calculator has a raised display that might be visible to other test takers, you will be seated at the discretion of your coordinator. So if you have a calculator with just some gigantic numbers on it, it's not that you can't use it, it's just that you may have to sit somewhere else. Calculators permitted include most graphing calculators, all scientific calculators, and all 4-function calculators, though they don't recommend those ones. So yeah, if you want to use a scientific calculator, it looks like you're good to go. And there's plenty of options when it comes to scientific calculators. Here I have one I pulled out of my desk here. This one's a TI-30XA. It's kind of an older one. But here you can see they have, listed a whole bunch of Casio ones. Here's a whole bunch of HPs, Radio Shack, Sharp, Texas Instruments. Yeah, there's lots of options. I have a couple of Casio ones. that I like to definitely use. And if you really don't like the price of the TIs, then I highly recommend going for one of these Casio calculators. All right, I got a couple of them here. Let's see what do I got. Have I not even opened that one? Oh, probably because it is a scientific calculator. I should really open that one up. So here I have a graphing calculator. This is the Casio FX9750G2. It's probably on this list somewhere, right? Yep. That one is an excellent calculator to choose from. It is a graphing calculator, and it is half the cost of the TIs. So, you know, that's a nice one. This other one is a scientific calculator, and this one is got a multi-line display, so it's fairly nice if you're looking at a very big expression. This one is the 115ES series. So it probably falls under this one, the graph. No, not the graph. What is it? FX11? Is it even on this list? I don't know if it's on this list. Most of the time it'll just say, well, yeah, this one is permitted on the SAT. Probably it's permitted because it is just a regular old scientific calculator. But that's also a nice one. I don't think I spent too much on that one. Probably like 15 bucks. Yeah, unfortunately, the TI calculators do have a little bit of a monopoly on them. That's also kind of why, boy, it's a real tough decision when it comes to deciding what calculator you should get. Because the TIs are way, way more expensive than the other calculators, but because they have a monopoly, it's like super easy to find out information on how to use them. In fact, if you go to your teacher and you ask them, how do I use my TI calculator, they'll probably be able to tell you. TI gives teachers and instructors a lot of information on how to use their hardware. I personally really like the Casios. I really do. But the downside with the Casio is when you want to know how to use the Casio, it is very tough to find someone who knows how to use it. So if you have a friend that also wants to get the same calculator, you can kind of bounce ideas off of each other, or you can check out some of my videos. I have videos specifically designed for how to use your Casio, and that can also help. Yeah. Good deal. Looks like someone is doing a trigonometry problem. Let me switch over to the trigonometry board. We'll see what we got. So this one says, I have a function test coming up, and I want to determine the angle that represents sine of theta, all equal to 1/2. Would I have to use something like special triangles in order to do this? Well, there's actually a variety of ways that you could approach this problem, so I'm going to show you kind of what leaps to my mind when I need to find a value like sine of theta is equal to 1/2. One of the things that comes to my mind is really trying to memorize the unit circle. And I know trying to memorize a lot of stuff in math can be very intimidating. But fortunately, you actually don't need to memorize the entire unit circle. You only need to memorize probably everything in that first quadrant. If you can get everything out of that first quadrant, then you have pretty much everything you need for the rest of the unit circle. You just may have to change your sign for a few different angles in here. So let's see, need a few more lines in here. These are going to represent some of the major angles that we have in our unit circle. Yeah. So these are the angles of, let's see, if you're dealing with degrees, this would be 0 degrees, 30 degrees, 45, 60 degrees, and 90 degrees. Okay, so those would be the major ones of the unit circle. Each of these have a value for a terminal point on that unit circle. So I'll just draw my unit circle out here. So this little green dot's going to represent where the terminal point for that unit circle is. And then I could start writing in the values. So the first one is at 1, 0. Let's see, the next one, that's going to be at the square root of 3 over 2, 1/2. Then I have the square root of 2 over 2, square root of 2 over 2, 1/2 square root of 3 over 2. And at the very top here, this would be at 0, 1. So when I have the unit circle like this, and I'm looking for the value of the angle, like sine equals 1/2, then I'm going to look at the second value in all of these terminal points. What I'm looking for is where is the second coordinate, where does that equal 1/2? And it looks like that will equal when theta equals 30 degrees. Now that really just gives me the place in the first quadrant, but then I'd want to really figure out places in the entire unit circle. So if I wanted to continue this around and find other locations, let me draw a really rough unit circle. So you have this one at 30 degrees. We'd have another angle over here that would have the same value of sine. So that'd be 90 plus, or let's see, I could do 180 minus 30, so that'd be at 150. So that'd be at another location. And of course, all angles that are coterminal with 30 degrees and 150 would also have the same value. Let's see, how could we list all of those out? That'd be quite a bit. So, and all coterminal. But 30 and 150 are the big one. Now, if you want to memorize something like the unit circle and do it painlessly and easily, check out my videos for the left-hand trick. Once you use your left hand to memorize those values, you can see where it doesn't take that long to be able to use it to write stuff down. Because honestly, I have a hard time memorizing stuff like the unit circle, but once I learned the left-hand trick, then it was like, oh, okay, I could know those values and it's not that bad. Yeah, you could also do this with special triangles. Let's go ahead and write down the special triangle. So if I didn't have a unit circle, if that was completely gone, no worries. Then I'd want to think of this in terms of ratios of triangles, or ratios of sides. That's what I want to say. So here we have our right triangle. It's got a nice right angle in it. And over in this corner, I'm going to represent theta. So sine would represent the opposite side over the hypotenuse. So 1 over 2. If I went through the solving process to figure out that third side, this is where we'd get that square root of 3. And actually, let's just double check that. I should double check. So 1 squared plus the mystery x side squared equals 2 squared. So 1 squared is 1, 2 squared is 4. Sure enough, we get a square root of 3, just like we should. Okay. So then I could look at the different sides on here and be like, oh yes, this is a special type of right triangle. So I know that this is 90. I know that the angle in question is a 30-degree angle. This angle up here actually happens to be 60 degrees. So yeah, that would really rely on memorizing some of those special triangles. That also works just as fine. You know, it's kind of funny looking at this list of calculators. I did not know that Radio Shack made calculators. I wonder if they still make calculators. I think they went out of business. Yeah, no problem. Well, I didn't know about that. I'm having a fun time looking at this list of calculators. probably not too surprisingly, I have a small collection of calculators. I think that's because when I was in school, I wasn't allowed to use a calculator. So when I got older, I started collecting them just as a way of being like, well, now I want to use these things. You are most welcome. Glad I could help out with that one. Maybe we'll make a video out of this one. Let's see. We will label this how to find Alright, so we'll label it something like this in case we want to make a video for label later. So this one we can say how to find an angle for a given trigonometric value. So how do you find the angle when you have something like cosine of theta is equal to that given value? As we can see, the part of this is either one way we can do this is, let's see, no, there's really two ways for doing this. One, we could go ahead and use the unit circle, or two, we could memorize various special triangles, and that would also give us a way of figuring out what the angle is. Sure, let's give that a try. That one looks like a good one. Yeah, we got some space here. Yeah, let's do it here. So this would be cosine of theta equals the negative square root of 3 over 2. Okay, that looks pretty good. The first thing I notice for this one is you're getting a negative value for cosine. And this will only happen in quadrants 2 and 3. So wherever this angle is, you know, if I really want cosine to be negative, it's going to end up in one of those two locations. And we'll probably just list out both of them, right? Probably. All right, so I'm going to write down the triangle. We'll do this using our nice special triangles. And cosine is the adjacent side over the hypotenuse. So negative square root of 3 over 2. So like before, I could do some solving and figure out what the missing side is. So negative square root of 3 squared plus the y side squared must equal the hypotenuse squared. So 3 plus y squared equals, oops, I should say 2 squared. That equals 4. Then we could go ahead and solve for y, get that all by itself. So subtract 3 from both sides, and we get that y is equal to 1. So yes, this is also one of our, nice special triangles. And in which case we can write down the angles that are present in there. So what is that? That is 150 degrees, or it's a 30. Let's do this. So this is 30 degrees. This one is 60. There's our 90. If I think about where this is in relation to my unit circle, that 30 degrees is right there. So the angle to get all the way out to the 30 degrees, that angle would have to be 150 degrees. Now the other place would be the 30 degrees down here. So I could go 180, almost, well, halfway around my unit circle, then go another 30. So the other one would be at 180 degrees. So those would be my two angles that give me the proper value for the cosine. And of course, all the angles coterminal with those would also give you the same value. I guess that should be my little disclaimer that I put on all of these. When dealing with these trigonometric functions, we tend to use just the ones that fall between 0 and 2 pi. But I guess there always is like this technicality. And all coterminal angles. Excellent. Anytime. All right, looks like we've reached the end of our stream. This is always a lot of fun, just sitting down and being able to answer questions for you. I always have a lot of fun, so I hope you have a lot of fun out of it too. Watch for my schedule. I'll probably put out a few more live streams this week, as well as in the future coming weeks. So if you do have some future questions and you can see I'm going to be online soon, feel free to just stop by and say hi or even ask your questions. Again, I have a lot of fun answering these. Hope to see you next time. All right, have a good one.